Hello and welcome. Today we are going to show HyperFlux requirements and electrical domain integration. HyperFlux is a meshed network of limited agentic AI agents. Each agent is responsible for one of 17 defined domains in aerospace. In the demonstration, a requirement will change. The systems pod will detect the change, realize that it is not responsible for that domain, then pass the information to the appropriate domain for analysis and change proposal. Let's get started. Here you can see our HyperFlux proposal interface. There are no pending proposals, so everything is in sync. You can see there is no history of approvals or rejections, since this is being used as a demonstration. In the real world, approvals and rejections are tied into your PLM, PDM system through a configuration management pod. But we have our approval for backup, debug, and demonstration. The knowledge management system allows you to add specific training to the AI agents. While we pre-ship each domain pod with some training, each company has their own ways of interpreting industry standards. The KMS interface allows you to add, delete, and override standards to meet your company's need. The KMS interface is restricted to administrators only. HyperFlux is tool agnostic. We create an interface between the pod and the tools without changing the core functionality. For the demo, we are using Doorstop. Doorstop is an open-source requirements management tool being adopted in regulated industries. Developed as an alternative to enterprise tools, requirements are stored as version-controlled text files. It was used jointly by NASA, Blue Origin, and Open Robotics during the development of the Space Robot Operating System, a flight-certifiable robotic framework to meet NASA software engineering requirements for Class A missions. Let's change the power to 150 watts. Notice I am only changing the parameter and not the text. Once I click into another field, the doorstop file is changed, and the systems pod gets to work. In the background, the systems pod is evaluating the change. It will then pass the information off to the electrical pod. Since it's power, let's wait for the change proposals to populate. This may take a few minutes since I am using an older remote GPU setup. Better hardware will mean faster responses. I've sped up this portion of the video some to respect your time, but in real time, this analysis takes a matter of seconds depending on hardware. What's happening right now is fascinating from an engineering standpoint. The systems pod is querying the system to identify every artifact downstream from this power requirement, SysML blocks that satisfy it, electrical schematics that implement it, test cases that verify it. It would be building a complete impact graph across multiple engineering domains. Each affected domain pod then generates its own reasoning trace explaining exactly what needs to change and why. This isn't instant AI complete, it's deliberate, traceable analysis that you can audit for certification. Every proposal includes the rationale, the affected artifacts, and the specific transformations needed. The deterministic core is doing Sparkle graph traversal to find relationships, while the AI pods are doing the domain-specific reasoning. That separation is critical. The core routes based on facts in the ontology, the pods analyze based on their domain expertise. In production environments with dedicated GPUs or on-premises inference servers, this entire cross-domain analysis completes in seconds. The wait is worth it. You're getting thoughtful impact analysis backed by formal traceability, not hallucinated guesses. This is engineering rigor meeting AI capability. And we can see two change proposals awaiting review and approval. We have one from the systems pod and a high criticality proposal from the electrical pod, highlighted in red. Let's look at the reasoning trace. We can see that changing from 90 watts to 150 watts is too much current for the existing harness. This poses a fire hazard. The electrical pod ran the analysis and saw this as high criticality in minutes. Now it waits for human review. For the systems pod, it's not critical, but it notices the text of the equipment doesn't align with the new parameter, so it informs the team. The truncated reading is a limitation of my test setup. In a deployed system, you would get a trace, just like the electrical pod. I hope this quick demonstration gives you an overview of where we are and where we intend to go. Please don't hesitate to contact us through our website or the email shown on the screen. Thank you for your time and have a wonderful day.